Hello everyone, welcome to Dakshana e-classroom program, and this is a solution video for DT10 NEET exam. So I hope already everyone has gone through the exam, and after going through this video you should be able to clear all your doubts in the questions which you faced in the exam. And after attempting the paper, your next objective is also to learn the things which you were not able to solve in exam. So I hope this video will be helpful for you people in that way. So let's see the question here. So here we have question number 1. Moment of inertia of uniform hollow hemisphere of mass m and radius r about various axes are indicated in the figure. Which of the following is correct? तो यहाँ पे एक आपको दिया गया है क्वेश्चन नंबर 1. Here we have given with a hollow hemisphere. It's like this. One axis is passing through this, so like this. This is I1. Another axis about this I2. तो यहाँ पे basically I1 equal to I2 will become 2 by 5. It's a hollow hemisphere, so 2 by 3 mr square. ठीक है ना? And another axis is this. तो यहाँ पे थोड़ा सा आपको समझना होगा कि actually this is I3 axis, and I3 axis it's not clearly mentioned, but definitely it will be like passing through the center of mass of this hollow hemisphere or center. So by perpendicular axis theorem, यहाँ पे अगर आप इसको थोड़ा सामने से देखेंगे then diagram will appear like this. It will be like this. So this is one axis, another axis, and this is hollow hemisphere. तो यहाँ पे एक एक्सिस है वो यहाँ से पास की इधर करके ऐसे, एंड दिस इज लाइक I3 एंड दिस इज I2 एंड दिस इज basically this is I2 and this is I1 or I3. तो by perpendicular axis theorem I can write basically here I1 plus I2 will be equal to I3, or this is what exactly it is asking. It is asking the relation between the moment of inertia of this body or hollow hemisphere about different axes I1, I2 and I3. So the correct answer here will be matching with option 1. So this is about the problem, and see the next problem. Okay, so the next question number 2. Here a circular disc X of radius r and made of from an iron plate of thickness T. Another disc Y of radius 4r and made of thickness made from an iron plate of thickness T by 4. The relation between the moment of inertia of Ix and Iy is. So this is the question. So यहाँ पे एक डिस्क है X जिसका रेडियस है R, thickness T, and because both are made of same, let's say, so the density, areal density is sigma. Then its moment of inertia Ix can be written as m into r square by 2. That will be sigma into pi r power 4 into t divided by 2. This will be the moment of inertia of Ix. For Y disk, the radius is 4r and thickness is t by 4 and density will be still same. So Iy can be written as same sigma pi into 4r power 4 multiplied by t by 4 divided by 2, and that will be basically 64 sigma pi r power 4 into t divided by 2, and this implies Iy is equal to 64 times of Ix. So this is the answer to the problem, matches with option 1. Okay, next question number 3. Here it's saying a thin circular ring of mass m and radius r is rotating about its axis with constant angular speed omega. 4 particles each of mass small m are kept gently to the opposite ends of the two perpendicular diameter of the ring. The angular velocity of the ring will be. So this is a simple application based on conservation of angular momentum. तो initially आप बोल सकते हैं L initial will be equal to L final, and this is m r square into omega, initial angular momentum, because ring, thin circular ring of mass m and radius r. So this is, and finally this is m r square plus 4 particles are placed at diameters. It will be 4 m r square into, this is omega prime, and this implies omega prime is equal to m into omega divided by capital M plus 4 times of small m, because r square will get cancelled out, and that matches with the option number 1. So this is answer to the problem. Next question number 4. A solid cylinder of mass m and radius capital R rolls without slipping down an inclined plane of length L and height h. What is the speed of its center of mass when the cylinder reaches its bottom? यहाँ पे थोड़ा सा आपको ध्यान से सुनने का है. Solid cylinder of mass m and radius r rolls without slipping. So it's basically rolling without slipping. तो इस सिचुएशन में क्या होगा? The decrease in potential energy will be getting converted into rotational kinetic energy plus translational kinetic energy. So decrease in potential energy will be equal to mgh, and this will be half m v square plus half I is equal to m r square by 2, so half I into omega square. And for pure rolling, तो इसके लिए आप बोल सकते हैं v is equal to r omega. तो r omega स्क्वायर को मैं v लिख सकता हूँ. सिंप्लीफाइंग इट कम्स आउट टू बेसिकली 3/4 m v स्क्वायर. और यहाँ पे अपन को पूछा क्या गया है? दिस इज आस्किंग द velocity of speed of center of mass of the cylinder when it reaches the bottom. Mm gets cancelled out. This implies v is equal to under root 4gh divided by 3. Yes, that's answer. So it's this is the answer, matches with option number 2. Next question number 5. Okay, so here it's saying a rod of mass m and length L is hinged at one of its ends as shown in the figure. A force F is applied at a distance x from A. The acceleration of center of mass varies with x as. तो यहाँ पे आपको क्वेश्चन में दिया गया है एक रॉड है which is hinged vertically like this and free to rotate, और यहाँ से इसके एंड से x डिस्टेंस पे फोर्स लगाया जा रहा है F. ठीक है ना? इसका मास m दे रखा है, लेंथ l दे रखा है. Then we need to find the acceleration of center of mass, right? So it's talking about acceleration of center of mass. तो यहाँ पे लिखेंगे tau will be equal to I into alpha, and that will be equal to basically F into x is equal to m l square by 3 into alpha. This implies alpha is equal to 3fx divided by m l square. तो ये आ जाता है angular acceleration. Acceleration of center of mass will be equal to 3, basically you can write L by 2 or L by 2 into alpha, that is basically 3fx divided by 2ml, and you can write here ACM is directly proportional to x. So the graph will appear like this, passing through center. This is acceleration versus x. So that matches with option number 2 here. Next question number 6. A meter stick of mass 400 gram is pivoted at one end and displaced through angle 60 degree from vertical. Okay, the increase in its angular speed. तो यहाँ पर है कि एक rod को, let me solve it here. Question number 6. A rod is initially like this and it's displaced by angle 60 degree from vertical. Okay, like this. So mass m and length l and सब कुछ आपको यहाँ पे दिया गया है. Then increase in its angular speed, so that will be basically again conservation of energy principle. So the potential energy change will be like, I can write here delta U is equal to delta KE. This is mg l by 2. This is 1 minus cos 60 degree. Okay, I can write it from here. This is at this much distance, and this is equal to how much? M L square by 2 into 3, half I into omega square. So simplifying it, this 2 gets cancelled, and 1 by 2, omega is coming out to be 3g by 2l. This will be the answer to the problem, and which is actually not matching with any of the option here, but the given answer here is 3, which is 3g by, so I think some 2 is missing here. The answer should be this one. Okay, so the next question number 7. Okay, next question number 7. A circular disc of radius capital R, thickness ry6 has a moment of inertia I about an axis passing through its center and perpendicular to its plane it is melted and recasted into a solid sphere. तो अभी पे क्वेश्चन नंबर 7, disk radius r, thickness r by 6, ओके, मोमेंट ऑफ इनर्शिया I, तो ये हो जाएगा बेसिकली डेंसिटी अगर मैं लेता हूँ दिस इज disk is, तो it's m r square by 2 and mass will be equal to what? It's pi r square into thickness r by 6 multiplied by rho. So basically effectively I will be m, or I can write simply it's m r square by 2 because m is anyway going to remain constant. Another thing is that it's recasted and into solid sphere, so the mass will remain or volume will remain constant, so pi r square by 6 multiplied by r should be equal to 4 by 3 pi r cube, and this implies r is equal to r by 2. Then mass will still remain same, so new moment of inertia of sphere will be equal to 2 by 5 m r square, because m is anyway going to remain constant. This comes out to be 2 by 5 into m into r square divided by 4, and this comes out to be m r square by 10. So then moment of inertia I can write I sphere will be equal to what? I disk divided by 5. So that matches with option number 3. Next question number 8. 4 particles each of mass 2 kg are attached to the rim of circular disc of radius 0.1 meter and negligible mass. Moment of inertia of the system about the axis passing through the center of the disc and perpendicular to its plane. तो ये हो जाता है सीधा सीधा मोमेंट ऑफ इनर्शिया, बट डिस्क का मास कुछ भी नहीं है, 0 है, तो यहाँ पे 4 पार्टिकल है, सो इट्स विल बी लाइक आई नेट विल बी इक्वल टू 4 multiplied by mass into r square. This will be, and substituting it, so this comes out to be, okay, it's 4, not 4, it's 5 particles, so I can write it's 5 into mass of the particle m into r circular disc of radius, so it's 0.1 into 0.1, this is 1 and that comes out to be 0.1 is the kg meter square is the moment of inertia, matching with option number 2. Question number 8. Okay, next question number 9. It's saying a rigid lamina is rotating about an axis passing through perpendicular to its plane through point O as shown in the figure. The angular velocity of point B with respect to A is, तो यहाँ पे आपको ये समझ में आना चाहिए कि एक रिजिड बॉडी में एंगुलर वेलोसिटी बेसिकली हर पॉइंट के अबाउट कांस्टेंट होती है, सो दैट्स वाई लाइक यहाँ पे ओके अबाउट एंगुलर वेलोसिटी में 5 दे रखी है, तो एंगुलर वेलोसिटी ऑफ B with respect to A will be also 5 radian per second, so that will match with option number 1. Question number 10. 4 thin rod of same mass m and length L form a square as shown in the figure. Moment of inertia of this system about an axis through center O and perpendicular to its plane. तो यहाँ पर है अपने पास ये सिस्टम, ठीक है, तो अपन क्या करते हैं यहाँ पे एक पार्टिकल जिसका मास m and लेंथ l है, इसके अबाउट मोमेंट ऑफ इनर्शिया m l स्क्वायर बाई 12 बाई parallel axis theorem. So I due to single rod will be like m l square by 12 plus m into this will be l by 2, so this will be like l square by 4, and that comes out to be 3 4, it's m l square by 3 multiplied by 4 rods, so I net will be equal to 4 m l square by 3. That will be answer to the problem, matches with option number 1. Question number 11. तो यहाँ पे है a solid sphere, hollow sphere and ring are released from top of an inclined plane frictionless, so that they slide down the plane, then maximum acceleration down the plane is. यहाँ पे थोड़ी सी चीज़ें जो आपको ध्यान रखनी है वो ये है कि यहाँ पे सरफेस फ्रिक्शनलेस है, सो नन ऑफ द ऑब्जेक्ट विल बी एक्चुअली अंडरगोइंग लाइक प्योर रोलिंग और accelerated, I mean like rolling motion. It's like simple sliding motion. In that case, the acceleration of each body will be simply g sine theta, and that will be same for all. So matches with option number 4. Question number 12. A sphere of mass 10 kg and radius 0.5 meter rotate about a tangent. The moment of inertia of the sphere, तो इस केस में sphere है, ठीक है ना, moment of inertia about tangent हो जाता है, it's I about this will be equal to 2 by 5 mr square plus mr square, so that will be like basically 7 by 5, mass कितना है 10 into r square is how much? R square is given as 0.5 into 0.5, so this one gets cancelled, 10 gets cancelled, and that comes out to be 3.5 kg per meter square is the moment of inertia of this part. That will be matching with option number 3. Next question number 13. So here it's saying a smooth sphere A is moving on a frictionless horizontal plane with angular speed omega, and center of mass has velocity v. It collides elastically and head-on with an identical sphere B at rest. ये भी दे रखा है आपको moving on a frictionless horizontal plane and smooth sphere. Okay, identical sphere B at rest. Neglect friction everywhere. After collision, their angular velocities are omega a and omega b. तो यहाँ पे है अपने पास एक ये solid rigid body है, omega a and v velocity, and it's striking. This is also smooth. यहाँ पे clearly दे रखा है, and surface is also smooth. Everything is there. तो यहाँ पे क्या होगा, देखो जब collision होगा, then only linear momentum exchange and redistribution will take place, because for angular velocity to change, some torque must be acting on both of the colliding body, but torque will act because of friction force, but no friction is present here, so nothing will happen to the angular velocity. So angular velocity even after collision will remain, omega a will be still omega, and b will be like sort of 0. So the answer matches here with third. Answer matches with option third. Next question number 14. In an equilateral triangle PQR, F1, F2, F3 and R, three forces acting along sides PQ, QR and PR as shown in the figure. What should be the magnitude of F3 so that the total torque about O is 0? It's a simple straightforward problem actually here. This is the situation. So this is, I can take like, let's say this distance is x, this will be also x and this will be also x. तो यहाँ पे जो force लग रहा है वो एक इधर है F3, that is okay, F1, F2 and F3 पूछा गया है यहाँ पे. So F1 है ये, it's given as 10 Newton, and F2 4 Newton and F3 पूछा गया है. तो यहाँ पे ये देख सकते हैं कि इनका दोनों का टॉर्क, सो नेट टॉर्क टाउ नेट शुड बी इक्वल टू 0, दैट विल बी इक्वल टू 10 into x plus 4 into x minus f3 into x, and this implies f3 is coming out to be 14 Newton. So that is answer to the problem number 14. Okay. Okay, next question number 15. A circular thin disc of mass 2 kg and diameter 0.2 meter. Calculate its moment of inertia about an axis passing through the as and perpendicular to the plane of the disc. तो क्वेश्चन नंबर 15, यहाँ पे आपको समझ में आना चाहिए डिस्क का, इसके अबाउट मोमेंट ऑफ इनर्शिया I is equal to mr square by 2 plus mr square, and that comes out to be 3 by 2 mr square. Substituting the data, 3 by 2, mass of the disc is given as 2 kg and its r is 0.1 into 0.1, so this comes out to be 0.03 will be the moment of inertia, matching with option number 2. Question number next 16. From a circular disc R, a concentric circular portion of radius small r is cut out so as to leave an annular disc of mass capital M. The moment of inertia of this annular disk about an axis perpendicular to its plane and passing through its center of gravity is, तो यहाँ पर है एक इस तरह का एनुलर डिस्क बना दिया गया है जिसका इनर रेडियस तुम्हें दे रखा है r, आउटर रेडियस कैपिटल R, जिसका टोटल मास m है। इसको हम इंटीग्रेशन से निकाल सकते हैं, तो I इज इक्वल टू इंटीग्रल, मैं इसकी मास डेंसिटी सिग्मा ले लेता हूँ, तो सिग्मा इंटू 2 पाई लेट्स से x इंटू dx, this is the mass, into m x square, this is the will be ring, so this and r to capital R, and this is 2 pi sigma into this is r power 4 minus r power 4 divided by 4, and mass will be equal to what, sigma into pi r square minus small r square will be actually mass, और इसको लिखा जा सकता है, this is 1/2, so this is pi and this is m by 2, this is capital R square plus small r square will be the moment of inertia, and that matches with option number 1. Next question number 17. 1/4 sector is cut from a uniform circular disc of radius capital R. This sector has mass m and it is made to rotate about a line perpendicular to its plane and passing through the center of the original disc. Its moment of inertia about the axis of rotation. तो ये एक स्टैंडर्ड क्वेश्चन होता है कि अगर कोई डिस्क है जिसका मास m रेडियस r है, उसका अगर एक पोर्शन भी कट कर दिया जाता है तो उसका जो फॉर्मूला है दैट विल बी लाइक स्टिल रिमेनिंग सेम, हाफ m r स्क्वायर। वहाँ पे जो नया मास है वो जो बचा हुआ है या फिर मतलब जो कटा गया पार्ट है उसका मास होता है। सो द मोमेंट ऑफ इनर्शिया फॉर 17 विल बी सिंपली हाफ m r स्क्वायर। यहाँ पे जो m मास है दिस इज द मास ऑफ दिस पोर्शन विच इज कट आउट, ठीक है ना। सो ऑप्शन विल बी मैचिंग विद लाइक आंसर विल बी मैचिंग विद ऑप्शन नंबर 1. Question number 18. A uniform heavy disk is rotating at constant angular speed omega about a vertical axis. So uniform disk, this is question number 18. Disk is rotating with angular speed omega. Heavy disk about an axis, about a vertical axis passing through the center and perpendicular to the plane of the disk. Let L be its angular momentum. A lump of plasticine is dropped vertically on the disk and stick to it. What will be constant for disk? It's asking for disk. इसका एंगुलर मोमेंटम इनिशियली L है। अब यहाँ पे कुछ लंप अगर पटक दिया जाता है तो उसकी वजह से क्या होता है कि सिस्टम का एंगुलर मोमेंटम तो कांस्टेंट रहेगा, बट यहाँ पे पूछा गया है कि डिस्क के लिए क्या होगा, तो डिस्क का डेफिनेटली ओमेगा कांस्टेंट नहीं रहेगा एंड एल भी कांस्टेंट नहीं रहेगा। सो आउट ऑफ द अवेलेबल ऑप्शन नाइदर ओमेगा नॉट एल विल बी कांस्टेंट, सो आंसर विल मैच विद ऑप्शन 4th. Question number 19. Alright, so uniform rod of length 2L is placed with one end in contact with the horizontal and is then inclined at an angle alpha to the horizontal and allowed to fall without slipping at contact point. When it becomes horizontal, its angular velocity will be. So here also it is basically change in energy, right? This angle is given as alpha, length total 2L, mass m, और इसको अलाउ किया गया है। तो जब ये ऑलमोस्ट हॉरिजेंटल हो जाएगा उस टाइम पे इसकी एंगुलर वेलोसिटी पूछी गई है। दिस इज हाफ m l स्क्वायर बाई 3 इंटू ओमेगा स्क्वायर विल बी द काइनेटिक एनर्जी एंड दैट इज इक्वल टू व्हाट, m g इंटू l इंटू साइन अल्फा। Simplifying it, m gets cancelled, 1l gets cancelled. This omega is coming out to be, this is all right, half, okay, just wait, okay, that's correct. So half I omega square is equal to mg. All right, okay, here length of this rod is 2L, so it will be like 4 will be here, and then simplifying it, it comes out with 3g into sine theta divided by 2L will root over this will be the angular velocity, that is matching with option number 1. Question number next 20. A wheel of mass 10 kg has moment of inertia 160 kg meter square about its own axis. रेडियस ऑफ जायरेशन विल बी, सो यहाँ पे मास दे रखा है 10 kg, I about central it's 160 kg per meter square, kg meter square. तो यहाँ पे अपन को पता है ICM is equal to m into k square, where k is the radius of gyration, so this implies k is equal to root over I 160 divided by mass 10, that is equal to 4. So k is coming out to be 4 meter, matching with option number 4. Next question number 21. यहाँ पे position of a particle is given by r I cap plus 2j cap minus k cap and angle and momentum p bar 3 I cap plus 4j cap minus 2k cap. Angular momentum is perpendicular to, तो यहाँ पे आपको angular momentum निकालना पड़ेगा L bar is equal to r bar cross p bar. Everything is given to you. Simplifying it simply, you will get it comes out to 0 I cap plus something j cap minus 2k cap. So in x direction angular momentum is 0 and it is in yz plane, so it will be definitely perpendicular to which? It will be perpendicular to x axis. The answer will be like first one, it will be perpendicular to x axis. Okay, next question number 22. The principle of conservation of angular momentum state that angular momentum always remain conserved. Definitely not. Is the product of moment of inertia and velocity? Also not. Remains conserved until the torque acting on it remains constant, so that is also not. None of these. So the best answer here will be like none of these. None of these will be correct. Question number 23. Radius of gyration of a disc of mass 100 gram, radius 5 centimeter about an axis passing through center of the gravity and perpendicular to its plane. तो radius of gyration तो इसके लिए रहता है m r square by 2 is equal to m k square and m gets cancelled. This implies k is equal to r by root 2 is the radius of gyration. So this is r is 5 divided by root 2 centimeter. That simplifying comes out to be 3.54 centimeter is the k radius of gyration for question number 23, matching with option number 1. Next question number 24. Infinite rods of uniform mass density and equal area of cross section having length L, L by 2, L by 4 and so on are placed one upon another as shown in the figure. The x coordinate at of the center of mass of the system. तो इसके लिए देखो सिस्टम है, this is one rod, another one, and so on. लेंथ इसका दे रखा है L, इसका लेंथ L by 2 है, इसका लेंथ L by 4 है, इसका लेंथ L by 8 है. तो अगर मैं लीनियर मास डेंसिटी लैम्डा मान लेता हूँ तो इसका मास कितना हो जाएगा? मास विल बी लाइक m इंटू लैम्डा, आई मीन लैम्डा इंटू L, और इसका सेंटर ऑफ मास हो जाएगा L by 2 पे. सो आई कैन राइट नाउ x सेंटर ऑफ मास विल बी इक्वल टू व्हाट? m1 x1 plus m2 x2 divided by total mass. So that will comes out to be basically lambda into L ml. This is m into L by 2. So L square by 2 plus lambda into L square by, this is what, इसका मास ही कितना हो जाता है? L by 2 lambda into L by 2 into L by 4. So it will be like L by 2 power 3 and so on. It will be lambda L square into 2 power 5 and so on. This is the m1 L1 divided by mass, that is lambda into L plus lambda into L square by 2 plus lambda into L by 2 plus lambda into L by 4 and so on. ठीक है, तो ये बन जाती है GP और इसको हम सिंप्लीफाई करते हैं एंड सॉल्विंग ऑन ऑल दैट. ये GP का आपको समझ आना चाहिए. सिंप्लीफाइंग इट यू विल गेट इट्स इक्वल टू L by 3 विल बी द आंसर टू द प्रॉब्लम, मैचिंग विद ऑप्शन नंबर 2. ये आपको GP सॉल्व करके गेट होगे देखोगे, देन यू विल गेट द आंसर दैट इज मैचिंग विद ऑप्शन नंबर 3 कमिंग आउट टू बी L by 3. Okay, next question number 25. Consider the following statements. Center of mass of uniform semicircular disk of radius r is at 2r by pi from the center. No, actually center of mass of semicircular disk is at 4r by 3 pi. So A is wrong statement. B. Center of mass of uniform semicircular ring of radius r is at 4r by 3 pi. This is also not right. It's 2r by pi. Center of mass of solid hemisphere of radius r is at 4r by 3 pi. Definitely not. It's at 3r by 8. Center of mass of hemispherical cell of radius r is at r by 2 from the center. So D is the right statement. Which of the following which statement is correct? So D is the right statement. So question number 25, right statement is D. Next, question number 26. A ball is dropped from height 5 meter. If coefficient of restitution is E is equal to 1 by 2, then time after which the ball stops rebounding. देखो इसको निकालने का तरीका तो ये रहता है, बॉल को ड्रॉप किए, नीचे गई, some velocity will be there, टाइम निकाल देंगे आप गिरने का, then it will be like coming up with velocity E into V. And then it will again strike. So time of flight, this will be sort of like projectile motion. Next time the velocity will become E square into V. So infinite collisions will be there. Calculate add all the times and then simplifying it, you will get the answer. The final answer here comes out with 2 under root 2h by g 1 plus E divided by 1 minus E is the actually answer of time of is it time when ball will stop. So substituting the values, 2h is 5, 10, this is 1, 1 plus 1 by 2 divided by 1 minus 1 by 2, and this is 1, this is 3 by 2, and it comes out to be 3 second is the answer to the problem. So that matches with the option number 3. Next, question number 27. Bullet of mass m hits block of mass capital M, the transfer of energy is maximum. तो यहाँ पर आपको ये समझ में आना चाहिए, जब दोनों बॉडीज़ का कोलाइडिंग बॉडीज़ का मास इक्वल होता है, एट दैट टाइम देयर इज कंप्लीट एक्सचेंज ऑफ मोमेंटम टेक्स प्लेस, एंड इन दैट केस ओनली द energy transfer is maximum. So the maximum energy transfer, the condition is that both the masses must be equal. So answer will be for 27 matching with option number 1. Small m is equal to capital M. Next, 28. A ball falls from height 5 meter and strike the roof of lift. If at the time of the collision lift is moving upward in the direction with the velocity of 1 meter per second, then the velocity with which the ball rebounds after collision. तो ये तो ऐसे समझो कि एक heavy object roof top of the moving with velocity 1 meter per second and ball falling from height of 5 meters, so its speed just before collision will be under root 2gh, that will be equal to 10 meter per second. So then we know the velocity after collision v1 is equal to m1 minus m2 divided by m1 plus m2 multiplied by u1 plus this is 2m2 divided by m1 plus m2 multiplied by u2. ये हो गया u2, ये हो गया u1. Substituting in all that, and m2 is because lift very greater than m1, तो यहाँ से अपने पास आता है v1 is equal to, and this will be like white minus and one more, यहाँ पे अपन डिवाइड करेंगे m2 से, so this will be like very small quantity, so this is minus minus plus 10 plus this again 2 multiplied by 1, that is equal to 12 meter per second is the answer, matching with option number 2 for question number 28. Next, question number 29. A 3 particle A, B, C of equal mass move with equal speed v along the medians of an equilateral triangle as shown in the figure. They collide at the centroid G of the triangle. After collision, A comes to rest, okay, while B retraces its path with the speed v. What is the speed of C? तो यहाँ पर आपको बेसिकली before collision, after collision, conservation of linear momentum apply करने का है. Initially it has speed v, this particle has speed v, and this particle has speed v. After collision, what is happening? This is A, this is B, and C. क्लियरली आपको दे रखा है. सो इनिशियल मोमेंटम, नेट मोमेंटम ऑफ द सिस्टम इज 0. ठीक है ना, ये आपको समझ में आना चाहिए. एंड आफ्टर कॉलिजन the figure they collide at the center. Okay, after collision A comes to rest. So A का तो सीधा 0 हो गया है, comes to rest. B retraces its path. तो B retraces its path moving with velocity v. And then what is the speed of C? तो आपको स्पीड पूछी गई है. सो इनिशियल मोमेंटम, तो ये तो सिंपली लाइक मैग्नीट्यूड, मतलब बोल सकते हैं कि यहाँ पे क्या होगा, बेसिकली स्पीड पूछा जा रहा है. इनिशियल नेट मोमेंटम 0 है तो फाइनल भी 0 होना पड़ेगा. तो इसके लिए भी क्या होगा, इसकी स्पीड पहली बात तो इधर हो जाएगी, दैट विल बी v. एंड बिकॉज देन ओनली इट इज़ पॉसिबल टू हैव नेट मोमेंटम फाइनल 0. सो स्पीड भी पूछे जा रहे हैं, वेलोसिटी पूछते तो डायरेक्शन वगैरह का भी सोचने का था. स्पीड विल बी सिंपली इक्वल टू v एंड दैट विल बी मैचिंग विद ऑप्शन नंबर 2. ओके, नेक्स्ट क्वेश्चन नंबर 30. इन ए परफेक्टली inelastic collision the relative velocities of the bodies, perfectly inelastic collision, तो इसमें आपको ये समझ में आना चाहिए bodies stick कर जाती हैं. Before impact is 0, definitely not. Before impact is equal to the after impact, no. After impact is 0, another of the, definitely after impact it becomes 0 because they stick. So the answer would be like equal to C or third one. Next question number 31. Two bodies A and B of equal masses moving along same straight line with the velocity of +3 and -3 meter per second respectively collide elastically. Their velocities after the collision will be. तो अगर दो बॉडीज़ हैं जो सेम मास की हैं, कोलाइड करती हैं, देन द कंडीशन इज दैट आफ्टर कॉलिजन दे सिंपली एक्सचेंज देयर momentum. So exchanging their momentum means exchanging their velocities. So the velocities of these bodies will become -5 and +3. So that will be matching with option number 4. Next question number 32. The quantity which remains constant in a collision. तो ये तो आपको सीधा सीधा समझ में आना चाहिए. Momentum, kinetic energy, temperature, no, not always. Momentum and kinetic energy only, no, not always. Momentum and temperature only, no. Only momentum, yes, momentum must always remains constant. So fourth will be like right option. Question number 33. Two identical balls in contact with each other resting on a frictionless table are hit head on by another ball of same mass moving initially with a speed v as shown in the figure. If the collision is elastic, which of the following is possible result after the collision? तो इस सिचुएशन में देखो, आप इमेजिन कर सकते हैं कि पहले बॉल 1 और 2 कोलाइड करेंगे, तो ये क्या आइडेंटिकल बॉल है, देन 1 will exchange the momentum with the 2, and then 2 and 3 are also identical, so 2 and 3 will again exchange. So 1 is coming to rest, 2 is also coming to rest, and 3 will be moving with same velocity. So the possible correct option will be like 2 for question number 33. Next question number 34. A ball of mass m strike a smooth ground at an angle alpha and is deflected at an angle beta as shown. The coefficient of restitution. तो coefficient of restitution की definition आपको समझ में आनी चाहिए. यहाँ पर ये है this, and here it's mentioned as this angle is alpha, and finally it's returning here this angle is beta. So let's say speed is u and going back with the speed v. तो यहाँ पे इधर क्या हो जाएगा, दिस इज u cos alpha and its velocity here will be like beta, so v cos beta. दूसरी बात, along the tangent direction, so this component will be like u sin alpha must be equal to this v sin beta. तो ये दोनों क्वांटिटी इक्वल होनी चाहिए. और कोफिशिएंट ऑफ रेस्टिट्यूशन बिकम वेलोसिटी ऑफ अप्रोच, मतलब सेपरेशन डिवाइड बाय वेलोसिटी ऑफ अप्रोच, v cos beta divided by u cos alpha, and equating these v sin alpha is equal to v sin beta, u sin alpha. So substituting the v by u will be sin beta by sin alpha, v by u will be sin alpha by sin beta, and simplifying it comes out to be basically this is equal to what, sin alpha into cos beta divided by sin beta into cos alpha, and this is coming out to be tan alpha divided by 10 beta. This is the answer which is matching with option number 1. Okay, next question number 20. This is the 34. Next question number 35. So I hope it should be clear. Two blocks A and B of masses 1 kg, 2 kg are connected together by means of a spring and are resting on a horizontal surface. The blocks are pulled apart so as to stretch the spring and then release. The ratio of their speeds. तो इस सिचुएशन में क्या होता है, देखो एक्सटर्नल फोर्स कुछ है नहीं सिस्टम पे, तो मोमेंटम नेट मोमेंटम इनिशियली इट इज 0, फाइनल मोमेंटम मस्ट बी आल्सो कांस्टेंट. तो आप बोल सकते हैं कि ब्लॉक 1 मास वेलोसिटी v1 should be equal to 2 into velocity v2. So this implies v1 by v2 should be equal to 2. The ratio of their velocities will be equal to 2. This will be equal to 2. So that is matching with option number 3. Next question number 36. A 5 kg cell kept at rest suddenly split up into 3 parts. If 2 parts of 2 kg each are found flying due north and east with the velocity of 5 meter per second, what is the velocity of the third particle after explosion? तो यहाँ पर है total mass exploding this, ठीक है. इसका mass है 2 kg, velocity 5 meter per second east, 5 meter per second north. Momentum कितना हो गया, 10 north 10 east. Resultant momentum will be like this side, 10 root 2 meter per second into kg. This is the resultant momentum, because initially the system has momentum 0, so final momentum should be 0. So net momentum of the final particle should be here, 10 root 2 kg meter per second. This will be equal to m into v, and m is given as 1 kg, so v will be equal to 10 root 2, and direction will be this. So it will be like due southwest. That will match with option number 3. Question number 37. A bomb of mass 12 kg at rest explode into 2 pieces of mass 1:3. If kinetic energy of the smaller piece is 216 joule, the momentum of the larger piece. तो यहाँ पे देखो 12 kg का है, स्प्लिट हो रहा है 1:3 में, मतलब मास कितना हो गया, इट्स 4 kg एंड इट्स 1:3, सो इट्स बेसिकली 3 kg एंड 9 kg. तो 3 kg की काइनेटिक एनर्जी तुम्हें दे रखी है, सो 1/2 into 3 into v square is equal to how much, 216. Simplifying it, we are getting v is equal to how much, 216 multiplied by 2 divided by 3. So this is 7 2, and this is coming out to be root over, so it's 12 meter per second. So momentum कितना आ गया इस पार्टिकल का, 12 into 3 36, and initial momentum 0, final momentum भी 0 होना चाहिए. तो मतलब दूसरे पार्टिकल का भी momentum क्या आना चाहिए, same and opposite direction. So momentum of the another particle will be equal to 36 kg meter per second. So the answer will be matching with option number 3 for question number 37. Okay, so next question number 38. A trolley of mass 300 kg carrying a sandbag of 25 kg is moving uniformly with a speed of 27 km per hour on a frictionless track. After a while, sand start leaking out of hole on the trolley's floor at the rate of 0.05 kg per second. The speed of the trolley after the entire sandbag is empty. इसमें थोड़ा सा आपको क्वेश्चन समझना पड़ेगा. बेसिकली 38, इसमें एक ये ट्रॉली है, it's moving and sandbag is there with velocity and sand is coming out here actually. इस सिचुएशन में क्या होता है, कोई रिकॉइल वेलोसिटी हॉरिजॉन्टल डायरेक्शन में नहीं मिलती है, सो दैट्स व्हाई देयर विल बी नो चेंज इन दिस वेलोसिटी. If there is some velocity in the vertical direction, that will change, but there is no velocity in the vertical direction, so that's why there will be no impact on this velocity, so it will remain constant. So the velocity of the cart or trolley even after complete sandbag is empty will be still remaining same, 27 kilometer per hour will be the answer. So that will be matching with option number 1. Next question number 39. Body of mass 9 kg explode into two pieces of mass 3 kg and 6 kg. If velocity of 3 kg piece is 16 meter per second, the momentum of 6 kg. तो यहाँ पर भी क्या है, मोमेंटम कंजर्वेशन. तो जो 3 kg का मोमेंटम होगा एग्जैक्टली 6 kg का भी मोमेंटम वही होगा. तो 3 kg के लिए मास 3 kg, वेलोसिटी 16 मीटर पर सेकंड, सो मोमेंटम विल बी 48 kg meter per second. That will be same momentum of 6 kg also, matching with option number 2. Next question number 40. If block shown in a figure are released from rest and distance traveled by the center of the mass in 5 seconds. तो यहाँ पे पहले अपन कैलकुलेट कर लेते हैं. This is the system, okay, and masses are given 2 kg, 3 kg. So acceleration of each block will be equal to what? So this is 3g minus 2g divided by, so it's g by 5, that is equal to 2 meter per second square. Acceleration of each block. Acceleration of center of mass will be equal to 2 multiplied by 3 minus 2 multiplied by 2 divided by 5, and that will be equal to how much? 6 minus 4, that will be like 2 by 5 meter per second, right? Then displacement of center of mass after 5 seconds will be 1 by 2 into acceleration 2 by 5 multiplied by 5 multiplied by 5. 2 to 5, 5 gets cancelled. This is 5 meter will be the answer, but that is matching with option number 3. That's correct. Next question number 41. So here it's given, from a circular disc of radius r, square is cut out with the radius as its diagonal. The distance of center of mass of the remaining disc from the center of the original disc. तो क्वेश्चन यहाँ पर है ये, और यहाँ से कुछ इस तरह का सिस्टम. दिस इज द डायगोनल, दिस इज आल्सो डायगोनल. एक स्क्वायर कट कर दिया गया इस तरह से, लाइक दिस. इसकी रेडियस r है, तो ये r बाई रूट 2 हो जाएगी इसकी साइड. और इस सिस्टम का, सो दिस इज बेसिकली कट आउट. सो सेंटर ऑफ मास, सो x थ्योरम, तो इसका रहता है, मैं इनिशियली इसका 0 0 कोऑर्डिनेट ले लेता हूँ, तो इसका सेंटर ऑफ मास, और डेंसिटी का सेम ले लेता हूँ, तो इसका ओरिजिनल मास लेट से m है, दैट विल बी इक्वल टू पाई इंटू r स्क्वायर इंटू सिग्मा. देन मास ऑफ दिस पार्ट विल बी लाइक m प्राइम विल बी इक्वल टू, दिस इज r स्क्वायर बाई 2 इंटू सिग्मा. ठीक है ना, और दैट वी कैन इवन डील इन टर्म्स ऑफ एरिया आल्सो. Then XCM will be like m into 0 minus m prime into r by 2 divided by m minus m prime. Simplifying it, 0 minus m prime will be like sigma into r square by 2 multiplied by r by 2 divided by pi r square minus sigma into r square by 2. Simplifying it, r square gets cancelled, 1 2 2 will gets cancelled. This is basically r by, माइनस का मतलब जस्ट इधर की तरफ होगा, अदरवाइज हियर इट्स टॉकिंग अबाउट मैग्नीट्यूड. सो 2 into 2 pi minus 1 will be the answer, that is matching with option number 3. Question number 41. 42. A mass per unit length lambda of non-uniform rod of length L varies with the distance x from its end according to the relation lambda is equal to alpha x, where alpha is a constant, the distance of center of mass from the x same end. इस तरह की सिस्टम के लिए यहाँ पे ये है, यहाँ से x डिस्टेंस पे एक छोटा सा एलिमेंट ले लेते हैं dx. लैम्डा इज गिवन एज अल्फा x. तो इस एलिमेंट का मास dm कितना हो जाएगा, लैम्डा x इंटू dx. देन xcm will be equal to mass into x into dm. dm is lambda x dx divided by, this is dm lambda x dx 0 to l 0 to l. so ये हो जाएगा बेसिकली lambda gets cancel, l cube by 3 और नीचे हो जाएगा l square by 2, so it come out to be basically 2l by 3. that is the answer, matching with option number 2. Next question number 43. So here 4 particles of mass m1, 2m, m2, 4m, m3, m and m4 are placed at 4 corners of the square. What should be the position value of m4 so that the center of mass of the 4 particles are exactly at the center of the square? तो यहाँ पर है ये स्क्वायर, और इसका मास है, दिस इज लाइक m1 that is 2m, this is m2 that is 4m, m3 is where, m3 is m, this is m4, ये अपन को पूछेंगे। मैं इसको origin ले लेता हूँ, this is x axis, this is y axis, then I can write now ycm should be equal to what, a by 2 if I am taking this side as a, ठीक है ना। So substituting here, a by 2 is equal to इसका 2m into 0 plus 4m into 0 plus m into a divided by plus, let me write this, plus m into a plus m4 into a divided by total mass to be pulled, this is 6m 7m plus m4. Write this, simplifying it, a gets cancelled and all that, so it's 7m plus this is m4 is equal to how much, 2m plus 2m4, तो इधर ले आते हैं 5m, इधर ले जाते हैं is equal to m4, so the answer for m4 is coming out to be 5m, which is not matching with any of these, so answer will be like here D, or basically it's fourth one and of these options given. Next question number 44, the position vector of the two particles is given as r1 and r2 respectively, the position of center of mass of the system, तो इसके लिए लिख सकते हैं position of center of mass will be m1 r1 plus m2 r2 divided by m1 plus m2, तो यहाँ पर आपको दे रखा है mass is 1 kg and 3 kg, so r cm, this is 44, will be like 2 I cap 3 j cap plus 4 k cap this, and plus 3 multiplied with minus 2 I cap 3 j cap minus 4 k cap whole divided by 1 plus 3 that is 4, ठीक है। सॉल्व करने पर ये आ जाता है 2, this is 6, this is minus 4 I cap and is 3 and 9 that is plus 12 j cap and 4 and minus 12, so it's minus 8 k cap divided by 4, that comes out to be minus I cap plus 3 j cap minus 2 k cap, and that is matching with option number 4, minus I cap plus 3 j cap minus 2 k cap. Question number 45, center of mass of a body lies always at the geometrical center. It's not true. That depends on the density or mass distribution of the body. Lies always inside the body, that also not always true. Sometimes it can lie actually, is it center of mass of body like this, it can be lying here outside the body. Lies outside the, no, may lies in within or outside of the body, so fourth one is the most appropriate answer. So this is all about your solution to problem paper DT 10. I hope this video should be like able to clear all your doubt based on this paper, and that's all. Thank you everyone.